Thanks for coming. Yes, this is a bit of slide title to get a short introduction of SUMO and how to work with SUMO with Python, of course. And the idea is to take some little introduction and then go into the demo, live demo, so we can go deeper into the capabilities of SUMO. That's the outline. So something about myself. The fun part, already Stefania told about the PyData and the database Venice. I'm a freelance transportation civil engineer. I've been working on mobility and transportation things for more than 10 years now. I have a PhD also in transportation engineering, and I used SUMO for about, I've been using SUMO for about 1 year, more or less. And the Python, of course, for several analyses about mobility in general in my professional life. Anyone here already heard about SUMO? No one? Great. So it's this is a C++ platform, open source platform, and able to build the networks, run and evaluate road traffic scenarios. It's a very huge package, so today we are just going into some introduction. You can see here that it is written C, C++. We have a good contribution of Python. There is also a little bit of Java. I don't know where, but we don't care about it. And this is what SUMO can do. So you can basically simulate, construct, build networks, road networks, but not only road, because you can also simulate pedestrian mobility, transit mobilities, railway mobilities as well. And there are several interfaces, visual graphic interfaces, where you can actually, in an easy way, you can build your traffic scenarios to evaluate. And we can see later in the demo, there are also some Python tricks to get in one click a full network ready to analyze. And so let's see the basics. How to build a network in SUMO. You can think about essentially a network, so nodes and edges. This is a basic T-intersection, road intersection, where we have 4 nodes and 6 edges. Think about edges of essentially lanes. So we have between 2 nodes, we have 2 edges, 1 per direction. And SUMO save all information about networks in a XML file. And basically, the network file is a .net.xml file. All the information related to the network are saved in this file. This is the offer, the network, but we have to build on another layer of demand on top of it. In this, we have the same intersection where we can build 3 routes. So essentially, give the itineraries of our traffic flows on the network. And on top of them, also the trips, so the amount of vehicles, essentially, in a certain period of time that can run from one point to another. And you can see also there is a small car in the beginning of the edge. So this is an indication that a traffic flow is assigned on the network. So basically, the simplest thing is to build a network, give some demand information, and then run the simulation. Simulation can be run also, well, this is the easiest way, via command line, where you can also define the network file you can read from, the root file, the additional files. These files are essentially needed for output simulation, so the simulation of the output. You can define several parameters and get those additional files out as XML files as well to later analyze the information. And the begin and end, well, you can define the time frame. These are seconds, so essentially you are analyzing 1 hour of simulation. And you can also store all the information in a configuration file and simply run sumo.sumo configuration file from the command line. I wanted to introduce 3 basic concepts that are essentially fundamental in transportation engineering and when modeling transportation networks. And these are randomness and calibration and validation. Actually, today we are not going to talk about calibration and validation because we don't have enough time. But I would like to get some information about how to handle randomness in SUMO, because SUMO is a stochastic platform. So essentially, you have to perform better simulation. You have to be sure that you have random distribution of vehicles when inserting in the network. And you can do this in different ways. Well, the easiest one is through a simple Python loops. So essentially, I can cycle through different seeds when I'm calling when I'm running SUMO. So essentially, going into different seeds of simulation. We have running 10 simulations with different seeds here, and getting the output files. We have here the first Python package provided by SUMO, which is simply converts XML files as output as a CSV, so it's easier to handle the things. And so this is the random, where random is important here. And this is where you choose the car following model. This is where calibration and validation is important, because SUMO works with different car following models. So essentially models that simulate the behavior of drivers when driving the cars. And you can choose different models, and it's an important thing. Of course, you have to calibrate the behavior of drivers based on real data on this particular model you are running. This is a small take I did some days ago about evaluating the intersection capacity. So essentially, the amount of cars that can enter the main road from a secondary road. So essentially, the right turn. This is on the top. You can see the SUMO model, and this is the potential capacity in function of the conflicting flow of the other vehicles on the other side. And you can see this is an analytical model. And we can run two different simulations with the two different car following models, the Krauss and the Weidemann 99. And you can see here is a band which represents the variability related to the different distribution that SUMO handled during the process. Let's have a look at some Python tools that are already implemented in SUMO. Essentially, this is a sumolib library. Essentially, you can work with this only to get information about the network and to work with the simulation outputs. Here you can think as a road network. So essentially, you can just go through edges, for instance, and retrieve several information. For instance, here the coordinates of the nodes, or the subsection of edges IDs, for instance. You can also go and parse all edges in a root file, and get information about vehicles and how they move around routes in the network. So essentially, it's a read mode with Python of your information that you store in the network. This is the cool things, because when you run SUMO and get the files out as output, I highlighted the things that I can extract from the simulation. This is the pollution emission. So essentially, the highlighted part is the most tricky part. You have to define the exact part where SUMO can read the information, and then plot essentially with the rest of the script is basically matplotlib, sorry. And you can get out a map with all the edges colored in function of the pollution emission. This is very cool. You can also do the same thing about speeds or congestion and so on. Okay, it's demo time. Let's hope that everything. So SUMO works natively on Linux. Yes? Sorry? Bigger? Ah, yes. Let's see if it works. I don't know. Well, but it just I'm just calling a script. Then later should be easier to read. Essentially, I'm running now the OSM web wizard.py. This is a script that automatically launches in the browser an extraction of the OpenStreetMap network. So basically, here I'm in Berlin because the developers are there, but we can change the location. So we're going to Firenze. And I can move, for instance, we should be here, in Garno del Tempio, yes. So I'm moving into our location of the PyCon. So we have several options of how to import the network. I can add polygons, so I can also have a sort of background of the network. I can select car-only network, so it's basically we work only with cars. We can also select the satellite background, but it should be a little bit heavy to download, so let's skip it. And we have also several options. Here we have we can put an initial count of vehicles that I can put, the SUMO can put and run in the network, essentially in a random way here. I can select the typology of vehicles. And then I can also select which kind of edges I wanted to import. So the highways or pedestrian paths, railways, etc. When I'm ready to go, I can, oh yes, the important thing is to select an area. So let's do it this way. And now I'm going to generate scenario. Let's go. Let's hope that everything goes well. And now SUMO, the script, is downloading the data from OpenStreetMap. Okay, good. And this is the SUMO GUI interface. So you see that I can import. I imported. See how the zoom. Okay. Okay. We have the network. Sorry. We have the network here. You can see that SUMO automatically imports also traffic lights. And from here, I can generate the simulation. So this is a parameter of delay, so we can see the cars running a little bit slower. And we can go with play. You see that now the vehicles are running. This is a nice thing because this is just a first take. So the traffic are inserted in the network in a random way, so random routes, etc. And I can scale up the traffic with this factor. So I can also go into 10 times the cars, okay? And I can also inspect several aspects of the network. For instance, I can go here, let's see, no, over the traffic light. Oops, sorry. Okay, no, there should be a show phases. Okay, yes, track phases. You can see real time the cycles of the traffic light, and then I can also here have some real time parameters. So I have the average speed in the network, the number of the running vehicles. So it's very nice. And the nice thing also is that I can color the vehicles in function of some parameters. So let's color by speed. You see that when vehicles are stopped, they are red, yes, okay, so the lower speed. Oops. And then I can also color the edges, streets. Instead of uniform, I can select by CO2 emissions, so the amount of emission from for each edge. You see, you have we have a bottleneck, so it worked. Right, we have a lot of traffic here, so. And then I can also go here, and the nice thing is to color by average speed. So yes, we have a bottleneck, big bottleneck, so everything is red. So that's essentially SUMO. And well, the nice thing, okay, you can have the graphic output, but still, as I said before, you can define different parameters to get out all the traffic data you needed. And then use Python. Essentially, I use the native tool of SUMO to convert XML outputs to CSV and then analyze with pandas or whatsoever, your favorite tool. And so this is only a small part of the platform because it's very huge, it's very big. And don't forget about calibration and validation. And that's it, I think. Thank you.
So thank you very much, Fabio. It's quite hypnotic, right? Yes. You can stay there. How much time do you spend just watching the cars going?
Oh yes, it's very cool. No, the thing is that yes, I didn't try yet, but the nice thing is that you can also insert tramways and pedestrian paths. So it's a very nice platform, and it's also very good supported because they release updates every 3 or 4 months, or more or less. Recently, I attended the SUMO conference, the yearly SUMO conference. It was online in May, and it's very good community also. It's very popular. Yeah. It is also, well, I use it for transportation projects, professional projects, but it's also used by researchers to get information about all the several things that physicists, can get out of the mobility stuff. So predict congestion or evaluate the best traffic light configuration to avoid the queues, etc.
I was thinking about that. So we have already a question. If you want to add anonymous questions, you can either just check the QR code, or the code for Slido is PyCon Italia 2022. So we have a question, very interesting one, about the speed limits. So can you implement yes. speed limits inside yes, that and see the behavior?
Yes, the default speed limit is 50 kilometers per hour. But you can, of course, change it.
Also by street?
Yes, you can select also by lane, I think. You can select your own traffic limit in terms of speed, for instance. Yes, of course. Let's see if I can also, because this is the, let's see. Well, when you run the OSM web wizard, SUMO saves all files in a specific, let's see, it should be this one, in a specific folder where we have the network file here. This is the configuration file, and should be the trips. Okay, yes, we have the random routes, but I can open with the net editor. This is the editor for the working with network only. Should be this one. Okay, yes. This is the network that we imported. So you see it's basically edges and nodes. Okay, and here you have the speed. This is meters per second, but you can change the yes, you can change the limit and save the network and run again the simulation. So yes. Oh.
Can you take into account the real speed limits of a street? Like
well, yes, it's a good question. This is the speed that I can insert here is the sort of free flow. It's called free flow speed. So the maximum speed that you can drive when there are no conflicts around. Okay. And then, of course, SUMO when run when it runs the car following models, the model, the speed is of course function of the congestion and of the conflicts about vehicles. I can insert here only the free flow speed, so the maximum speed allowed when there are no conflicts about among vehicles. Yes.
Oh, that's interesting. I actually have another question, if there is any in the slide, but also here in the chat. Oh, we have new questions, so let's go ahead with this one. So can you stream the data real time also by running simulation, or?
Do you mean the streaming from SUMO out?
Yes,
okay, from SUMO out.
Running simulation.
I don't know, actually, but I think so. It might be, or might be a good feature to ask ask for. Yes, I didn't try it. Let me. I think so. I think so. Might be a good feature to.
Yeah, a good
to ask
development
for
to ask for that.
Yes, yes, yes.
Oh, that's very interesting. And what about the layer? You can add the layer of maps, for example, for rural area, in order to make the simulation more realistic, perhaps?
Well, from the with the OpenStreetMap importer, I don't think so, because you can select the layers, but also only in terms of network. I don't think that there are particular backgrounds that you can download and select.
Okay, I don't think that would be interesting to add. Also
as
for
far
the
as I know,
accessibility of the street themselves. Yeah. And what about the output of the simulation? Like, it can be like a file that can be runnable or embedded perhaps in a website, or something that would be more, is meant to be local and have the simulation, or yeah?
Well, essentially the output files are basically not so easily readable. So because there are XML files with essentially for every instance of simulation, you can have I don't know the speed for each vehicle. So you can track each vehicle in all these is stripped through the network. In each point, the actual speed, the delay, and you can also aggregate data for intersections or for single edges or single lane, and get out the maximum delay, for instance, or the maximum length of the queue. But it's not well. In my experience, you have to deal with the output file and get sort of good yes, or aggregate or get some cool outputs to understand the behavior of your model. Yeah.
That's interesting. I have a question about, so sometimes I worked with well, not every time, but I had the experience of working with some data for insurance company that have black box in the car. Yes. And I know that the insurance company of the cars can raise your insurance based your good and bad behavior on the street. So I was wondering, is it possible somehow by each car to simulate bad behaviors somehow? So in order to see how the traffic gets more close or less, or reinforce the behavior of each car.
I think so. Maybe you can select a bunch of vehicles with some good, bad behavior, and put them random in the network. Maybe you can. Yes, you can also define the. Well, I don't know if you can define different car following models. No, but for each or for a bunch of vehicles, you can modify their attitude of driving. Yes, and I think so. Yes, there is also a package where you can simulate an accident on the network and get some emergency vehicle that can, have to enter in the network and reach the point of the accident as soon as possible through the network. So something like that. Yeah, it's very nice.
Yes, because a question could be a follow-up of that. It was how about the different agents? So you can also add, I don't know, ambulance, police going on. So for example, they have the priority of the street that then cars have to move. That could be a different, quite difficult to simulate, but just in order of priority, basically.
Yeah. You can define priority corridors on routes, priority routes. But I don't know how it worked with the emergency situation. Yes, as far as I know, there is this tool that where you can simulate these kind of things, where an accident happened in the network and some vehicles have to go as soon as possible in the shortest pathway into that point. But I don't know if actually can run through priority corridors. I don't know.
And what about humans?
Yes,
can
humans. I didn't
pedestrians
try. Yes,
going
there are
around?
pedestrians that I can also simulate pedestrians things, and when I have an intersection, so I can of course get some information about priority. So of course, is a traffic light or not? I can get a higher priority to pedestrian paths over vehicles. But it's I didn't try. But it's also very useful to simulate only with pedestrians. For instance, if you have, I don't know, a metro station or railway station, very huge hall, and you have to simulate an emergency, so you can simulate how people can exit in the right way, or the building or the station or whatever. Simulating we have the car following models for the cars. And we have also models for the behavior of humans when they are conflicting to each other when running and working.
Oh, well, that's very interesting. And actually, I have another question about public administration, because it's happened that can get a lot from this. And I was thinking about if you know if they've been in contact with them in case of emergency, or in case of running simulation, in order to be a better service for the public, for the citizens.
Yep.
And yeah, what's your experience that,
well,
if you know?
Actually, yes, it's in my own experience, because I worked also as a consultant for public administration about mobility. The problem is that public administration usually don't have so many technicians that are able to run those kind of tools, because you have to get some skills of at least of programming, and usually they deal with the commercial software, which is very expensive, at least a little bit easier to use, user friendly, and but this might be a good occasion to introduce maybe some other stuff into public administration, at least because it's, well, one is free. And secondly is you can implement everything, yes, everything you want, public transport, etc. Instead of commercial software that they ask for money for every layer you wanted to add to your network, and it's crazy.
So talking about administration, we know there's different rules based on country. Is actually some version of it country-based, or there is some add-ons of the library that can be used?
Mm-hmm. Well, when you import the network, you can select the left or right way of yes, this is the first thing about the network. But secondly, when I talk about calibration, yes, that's an important thing, because if we have a simulation in Florence or in Rome instead of Copenhagen, I think that the behavior of the driver is very different. That's why I focused on the importance of calibrating and validate the models, because in that case you have to take some real data. Essentially, when you calibrate a network, the easiest thing is to get some real-time traffic flows from intersections, and essentially count how many vehicles can pass when the light is green on an intersection. This is called the saturation flow in transportation engineering. So the maximum amount of vehicles that can pass with the green light, and from that you can start to calibrate, yes, the behavior of the driver. So how much you can stay close to the vehicle in front of you, etc. So these kind of things.
Yeah, that's interesting. Actually, probably based from different country, you have to take into consideration also the parking behavior in the middle of the street, and people that just cross with the red lights or yellow. And
yes, there is the ideal world, and then you can just pass through the real one.
Yeah. So if there's no other questions, another big applause for Fabio Lamanna.